So the CMS detector detects different particles that are created during particle collisions. And during your master class, what we're going to do is we're going to look at some actual data from CERN. So the events that were recorded by CMS and interpreted by scientists are some of the same things that we're going to be doing as well. Now, CERN has released this fabulous program called iSpy, and it was developed specifically for the CMS experiment, and it has been made open source for the general public to use and explore this kind of thing. So when you first open it up, it looks pretty empty. But this is right here, this big cage looking thing. You can click on this and you can drag it this way. You can set that orientation. The big yellow cage cylinder represents the detector barrels of the CMS. So during the masterclass, you and your partner are going to be analyzing some of these particle collisions and looking at the signatures within those barrels to determine what those particles are. So what we want to do is we want to add data. So up here under Open. Now, there are files from the web, and there are some samples. When you get to your masterclass, they will give you a very specific set of samples. Right now, we're just going to look at the masterclass samples. So over here, this is run 1, which was the first run of the LHC, and the event that you have. So we're just going to open event 13, and we're going to load that, maybe. So you see in here, these are the signatures that you can see. Now you can zoom in, you can zoom out. Oops, wrong way. So you can zoom in a little bit. So these are the signatures that you can see. So you see a whole bunch of squiggly yellow lines that appear, and if you look closely, you can see some green and blue shoots as well. It's actually the green ones that we're kind of interested in. So in the left-hand menu over here, we want to change a few settings. We want to make sure that this eCal barrel is turned on. We want the HCal barrel, no, not the HCal barrel, the HCal outer. That's what the yellow is, that's already on. The event, where is that? I think it's down here further. The event's on, the tracks are on. We want to turn those off. If we turn those off, we can see just those green lines. So we don't really care about those yellow squiggly lines at this point in time. And then we also want the photons and the missing energy turned on. And the electrons should be turned on as well. So those are the settings that you want to use when you're interpreting this data. So it's here where now we're going to attempt to identify the particles that are produced during this particular event. So the first thing we need to know is what kinds of particles will we actually be able to see. In the iSpy program that we are using, there are 3 main categories of particles that we will come across. There's the W bosons, the Z bosons, and the Higgs bosons candidates. Now, W bosons are particles that decay into leptons and a neutrino. And remember that a lepton can be either an electron, positron, or muon. A neutrino is shown as missing energy. So remember when we came over here and we clicked this button and this pink dashed line showed up? That's missing energy that cannot be detected. So remember, neutrinos don't have charge, so they don't interact with our magnetic field within our detector. So this pink line right here shows us where we see that missing energy. And this was the same as the missing energy that we did with the top quark mass activity when we found that extra vector. So a pink dashed line means it's a neutrino. If you have a solid green line, like this one right here, this is an electron. Because it has a negative charge, it will curve counterclockwise in its path. Now, if we look at that green line right there, it does not look at all like it's curving counterclockwise. The best thing to do is to take a piece of white paper and just put that straight edge up along here, because sometimes we can't really see that. So if we take a piece of paper and we put this right here, we can see maybe a tiny little curve, and sometimes that's just going to be really difficult to see. But an electron in this particular magnetic field would turn to the counterclockwise direction because of its negative charge. Now, a positron track will also show up as a green solid line. Remember, positron is an anti-electron. So it will also show up as a solid green line, but it will curve clockwise. So if we hold our paper up right here and we see that it curves in the clockwise direction, then it's a positron. So holding up this piece of paper that you can't see, When I hold this piece of paper up, we can see a very gentle curve in this counterclockwise direction. So here in this particular event, we have this dashed pink line, which is a neutrino, and we have a solid green line curving counterclockwise, so it's going to have an electron. So once you identify these, what you're going to do is you're going to go to the CEMA website. This is again going to be given to you, and you will have very specific things to open when we get there, and you'll see this a little bit better. You're going to select your event, like our event, for example, was event 13. This is not the same file menu, so I'm just kind of opening this. So once you identify the particles, you're going to record the data at the CEMA website. So record the final state by checking either electron or muon. So we had an electron. And we want to indicate the primary particle by choosing a W positive if the lepton is positive. Okay, so if our electron and muon were our leptons. So W positive if the lepton is positive or curved clockwise. And it was not a positron, it was an electron, so we're going to choose, whoops, I forgot to click on. It's an electron, it's a W negative boson, and then you're going to hit submit. Okay. So in this particular situation, we have an electron because it's curving counterclockwise, and so our primary state was going to be a negative boson. So let's go back here and let's do another one. So we're going to open this up. We're going to just choose, just go down the line, choose another event. So this is event number 52. Now you have some kind of weird looking things. Those are actually muon chambers. Let's get rid of that. We don't care about that at all. So what we've got here, we have this dashed pink line. Remember that means it's missing energy. So that's going to be a neutrino. But now instead of a solid green line, we have a solid red line. So a solid red line is a muon track. It can curve clockwise if the muon is positive and counterclockwise if the muon is negative. And again, just looking at it, it looks pretty straight, but if we take a piece of paper and we hold it up there, it looks like it's curving in the counterclockwise direction. Okay? So taking a piece of paper and holding it up there is a very, very slight curve, but I would say it's maybe curving just a little bit to the counterclockwise. And you can actually zoom in a little bit and see that a little bit better. Okay, so you can kind of see, it's very subtle, but there's a definite counterclockwise curve to it. So in this case, when we go to our CEMA site, we're going to choose a muon because it's a solid red line. And since it was curving in the counterclockwise direction, it would have again been a W negative boson.